Yeah, thanks everyone for coming to my talk today. I'm excited to be zooming in remotely from Michigan. So today I'll be talking about this conservation practice called translocations. Giving a little intro about that, and then again providing a little bit of a little update on some of my work that I'm conducting related to that. So I am starting my talk with a little bit of a dire reminder that we are all currently experiencing and living through a pretty extreme avian conservation crisis. And so one kind of clear example of this, based on some research that was published a couple of years ago now, found that from 1970 to today, avian populations in the US have dropped by nearly 3 billion individual birds. And this is affecting a lot of different species, including some of the ones that we think of as the most common and widespread. For example, red-winged blackbirds and juncos and white-throated sparrows have all dropped. Their populations have dropped by tens of millions of birds, which is pretty scary. And so my research interests, and generally I'm driven by this broader question of how do we mitigate this unfolding avian conservation crisis. And there are a variety of drivers that are driving these widespread conservation, or these widespread population declines. However, one of the most salient, or one of the most pressing, is the widespread human-mediated transformation of land cover across our planet. So one clear example of this, and it's relevant to the species I'll be talking about a little in more detail today, is the forests across our planet. So this map is showing over the past decades forest loss across Earth. And so parts of this map that are highlighted in brighter colors, for example, in the Southeast US and in the Amazon and in parts of Asia, these are places where we are experiencing a lot of destruction of forests. Alongside these, the reduction in the amount of forest we have, there is pretty widespread fragmentation of forests. So the remaining remnants of forests in many places are in these little patches that are separated from other forests. And a lot of these, increasingly forests are located near like a habitat edge. There's less core forest. And then alongside this destruction and fragmentation, kind of the fundamental identity or features of these forests are changing through time. One example is that because of the destruction of these old growth forests through time, forests are collectively becoming younger through time. And so the upshot of this for species that rely on forests or other habitats that are experiencing these things is that it is pretty difficult for populations to persist in fragmented landscapes. And to kind of talk through this a little bit, I have a little toy example here. This is a land cover map of a part of southern Dakota County, so a few miles south of you guys. And this little land cover map has a couple colors. The yellow is agricultural land. The little red spots are built environments like buildings, and then these little green patches are forests that are remaining in the landscape. So these patches are pretty small. And so each of them can, if we're thinking about a species that relies on this forest habitat, each of these habitat patches can only support a small population. And these are pretty vulnerable to disappearing, or sometimes it's called extirpation, for a variety of reasons. One example is, maybe you've heard of this concept of inbreeding, where there's mating between close relatives. This can result in some reproductive consequences and lower performance of individuals. And so that's one threat of being this small isolated population. And so one thing that can generally be beneficial is movement, or connectivity between these different populations and habitat patches. This movement of individuals between these patches can offer a bunch of benefits at the landscape level. One is that maybe there's a habitat patch out there, and would be good habitat And if individuals are able to move over to that or disperse over to that unoccupied habitat, maybe they can colonize that little habitat patch and start a new population. And then in addition, for these small populations that are existing, the movement of individuals into those existing populations can mitigate some of those small population problems that threaten the existence of these small populations. But often, because we fundamentally transformed landscapes across our planet, this is often not possible. Little populations are isolated, and this includes, you might be thinking about birds and how they can fly, but there's many species, including the one that I'm talking about today, that they don't disperse very far. They don't like moving across habitat that isn't their favorite, and so even for birds, this isolation can happen across landscapes that we've transformed. So to combat the pitfalls of being these populations being small and isolated, ideally what we would do is restore natural connectivity across our landscape. And so one kind of small palpable example of this are these wildlife overpasses that are popping up across the planet. Here's an example of one that has recently been built in Singapore. And this can, foster connectivity, but, often we can't naturally restore this connectivity. And so because we've fundamentally transformed so many of our landscapes. And so what we can turn to is when we can't restore this natural connectivity, we can turn to translocations. And so what is a conservation translocation? Well, this is simply the intentional movement of individuals from one location to another for some sort of conservation benefit. And this encompasses, a bunch of potential motives. One is that maybe you have a small population that isn't doing very well, and you may want to add or augment individuals into that population to benefit that population. One species where that's been done in several places is the greater prairie chicken shown here. Another reason we may want to do this is perhaps the population disappeared, or perhaps we restored some habitat and there is, habitat there for a species, but there isn't any individuals there, and so we can establish or reestablish populations at an unoccupied habitat patch. And another reason we may want to do this is perhaps there's a population that is experiencing some sort of existential threat. Maybe, that habitat is about to be destroyed and we can't avert that destruction. And so one thing we might want to do is take individuals from that habitat that's about to be destroyed and move them to a protected area. And that it has happened, for example, with the Florida scrub jay down in Florida, where there's pretty extensive destruction of their scrub habitat that they rely on. And so, one of the goals of this talk is to kind of just like make you more broadly aware of this conservation practice, and also to let you know that, we are reaping the benefits of this conservation approach in Minnesota and across the US and across the world. So a couple examples of this that you may or may not be aware of is the wild turkey has benefited a lot from conservation translocation. So this was a species that was, a couple hundred years ago, was found across around 40 states. That's highlighted in that teal color here. Because of unregulated hunting and habitat destruction, the populations of wild turkeys reduced down into these dark blue areas, down to just, a couple dozen states in the Southeast, and there's only a couple 100,000 individuals, I think, in the global population. However, because of translocations throughout the 1900s that occurred both within their original range and then also beyond their range, that is what the burnt orange colors are shown here. The wild turkey populations in the US have really expanded in its extent and also in the amount of birds. There are now a couple hundred or a couple million individuals in the population in the US, and there are self-sustaining populations across the lower 48 states in every state. And so one reason that we have, turkeys in our state right now, this is a very common backyard bird, we can thank translocations for that. Another perhaps example that of in Minnesota is the trumpeter swan. So this was a species that was extirpated or disappeared in the state in the 1800s. And so it wasn't in the state at all, but translocations from populations from Western US and Alaska in the second half of the 1900s started a new population in Minnesota. And then so in the late 1900s, there was nearly no individuals. And then, throughout the 21st century, there's been this really rapid increase in trumper swans throughout Minnesota. And now we're numbering in the tens of thousands. And this was this was from 2022, I think, is when this plot ends. But now I think we're up to nearing or beyond 40,000 or approaching 50,000 birds. So another example of how translocations have, the birds that we see pretty commonly now are here because of translocations. And so these, to me, are really inspirational examples of how translocations can be used to benefit these birds that we love so much. And this is, inspirational things for me. And so there's a couple of questions that I have when I look at these. And so I've, shown a couple of successful examples, and there's also unsuccessful examples of translocations that I didn't really talk about. But, the questions that pop into my mind are like, how exactly do these translocations reshape populations, and how exactly are these translocations beneficial? And these are, important questions to address because we can use this information to develop more efficient and effective ways to implement translocations to benefit populations that are in peril. And so with that, I'll share some of my own work related to this that is looking at one case study of translocations. And this is in a species that is not found in Minnesota. This is the red-cockaded woodpecker. But hopefully, you won't be able to find that in Minnesota this spring, but hopefully I will convince you that this is a pretty cool species that if you ever get to the Southeast US, you should take a look at them. So the red-cockaded woodpecker story, this is a specialist of old growth pine savannas in the southeastern United States. So this is their current distribution, or kind of like a course level map of where they're found. They're found mostly, in about a dozen states in the Southeast US. This is what their habitat looks like down in Florida, and the population, these really kind of old growth pine savannas where there's very little understory or mid-story vegetation, and it's kind of these old gnarly pine trees. However, this type of habitat was extensively destroyed and altered throughout the 1900s. And so this resulted in a pretty extreme population decline for the red-cockaded woodpecker, unfortunately. Because of that, it was actually in the first batch of species that was listed and protected under the United States Endangered Species Act when that was ratified in 1973. And that listing prompted pretty concerted and extensive range-wide conservation efforts, including these conservation translocations that I have been talking about. And so this is like a birdie crowd that likes birds, so I wanted to share a little bit about their biology more generally. They're a pretty unique and interesting species, I think. So this is a non-migratory species that they actually exist and defend these year-round territories. They are a cooperative breeder, which is a pretty unusual breeding strategy in birds. And so this consists of usually male and female who are the breeding individuals in that little group that's occupying a territory. And then they sometimes have a handful of their male offspring from previous years that act as helpers at the nest. So they sometimes incubate the young, they feed the young, and they do other things throughout the territory. The offspring females generally don't stay on as helpers. They fledge and then they head out to find their own place. They are the only, I think I have this right, that they're the only woodpecker that's known to exclusively rely on living trees for roosting and nesting. And they mostly rely on living trees for foraging too. And this actually, is associated with some benefits and some difficulties. So one difficulty is that, it's hard to make cavities in living trees. And so cavity creation typically takes several years, but can actually take multiple decades to complete, which is a very long time for these fairly short-lived birds. And so if you were, to go out and follow these birds around in their territory, you would see them foraging a lot. You'd see them interacting with each other. They're pretty social. And then you'd see them just grinding away, like working on these cavities across their territory. And so that's kind of like a difficulty of relying on these living trees. But one benefit is that one thing that they do is they maintain these resin wells near the entrance of their cavities. One example of these resin wells is shown in this picture here. And because this is a living tree, these little wells leak resin regularly, and this coats the trunk of the tree. And this is a pretty effective deterrent against potential nest predators. Specifically, the black rat snake loves, if possible, to get into these cavities and eat the young and eggs. And this resin well strategy is a pretty effective deterrent against them. So there are benefits to relying on these living trees. So the specific population that I am studying is at this military base down in Florida called Avian Park Air Force Range. This is an active military training facility. So if you were, to go down there, you'd see lots of planes flying over and lots of bombs going off. This site has one of these small isolated populations, similar to many other populations across the species range. This population, so to give you a little, orient you geographically, Avian Park is down here in southern Florida. And then this population has experienced or has received exactly 54 translocations from populations in northern Florida and also Georgia. And so showing the timeline here, that's happened. There's been this slow trickle of translocations that have been put into the population for a couple decades. Excitingly, this timeline here starts in 94 and goes through the present. Today, I'm just talking through 2022, I guess, but this population has been intensively monitored throughout this time, which is the data that, represents or, facilitating my own work. And so what this monitoring looks like is that the monitoring is pretty remarkable. This population is almost like comprehensively banded. So every single bird in this population has a unique band. So you could go down to this population. If you got a good look at their legs and the band combo, you can know exactly who each bird is. Since 1994, nearly every single nesting event has been monitored, and the outcome of that nesting event has been recorded. And because we know who all of the breeding individuals are, and we know who all the offspring are, we actually know how basically every single bird is related to each other over this time period. And so from that, we can reconstruct or we can document the family tree or pedigree of this population. And collectively, this information gives a ton of information about, how the population is changing through time and the impacts of these translocations that have happened alongside this monitoring. And so I want to, thinking about taking a step back and thinking about like what makes a successful conservation translocation. And again, there's potentially, several motives, but the three that I will focus on today, I'll have a little checklist of criteria here. One is that we, a really basic thing, but very essential, is that we need these translocated individuals to successfully survive in this population and reproduce. If they leave the population right away or they die right away, that's, they'll have no impact on the population. Often these conservation translocations are happening in these really small populations. And so we want to see the population to experience some growth and to get bigger. And then lastly, what we want is the translocations to diversify the genetic composition of the population. There's a whole host of potential benefits that come along with having a more genetically diverse population. So that's something else we would hopefully see alongside or because of these translocations. And so if we look at, let's see, what's happened at Avian Park. This plot here is showing a timeline of the translocations. Above the horizontal line are birds that successfully were able to establish in the population. And then below, those like lighter bars are birds that were translocated in but weren't seen again. And so across all these translocations, nearly 70% of these translocated birds successfully established, which is a really remarkably high percentage and really wonderful to see. Also excitingly, so we've been documenting all these nesting activities. We're able to look at the reproductive success of these translocated birds, and these translocated birds are actually reproducing quite well and actually collectively better on average than the non-translocated resident birds. And so they are establishing really well and they're reproducing really nicely. Perhaps even more excitingly, if we look at all the locally hatched birds at Avon Park, so we exclude the translocated birds and we're looking at just the birds that locally hatched, we can look at the extent of ancestry that each of these birds has inherited from one of the translocated birds. And we can get at this with the pedigree information. So that's what's shown along the horizontal plot or the horizontal axis here. And so what we can see is that as a bird's amount of translocation ancestry increases, birds tend to survive better and they tend to show higher reproductive success. And so what this indicates is that there is this multi-generational benefit of these translocations. Not only are the translocated birds going into this population and doing really well, but actually their descendants are doing well and better than birds that have less ancestry from the translocated birds. So this is really exciting to see and clearly supports this first criterion that the translocated individuals and their descendants are doing well, they're surviving and they're reproducing. If we look at the population size through time, so what we're looking at here is two things. One is the number of breeding groups or territories in this population through time. And then the bottom is the census size. So if you go out and count every single bird that, they do that every year in this population. And then these numbers represent when the translocations happened. What we can see is at the beginning, there's a slight decline or kind of a consistent decline. And then alongside and after these translocations, both the number of territories in the population and the overall number of individuals, the census side has consistently increased. And so this is really exciting to see and pretty clearly supports the second criterion that I laid out here. And then with respect to this last goal, diversifying the genetic composition of the population, we don't actually have, well, I'm currently trying to get that, but we don't actually have genetic data, but we can kind of get at this with the pedigree that we've documented over the past several decades. And so before I jump into the results, I just want to provide a little bit of an interpretation of what I'm going to show you. So each of these bars represents an individual. And it is colored by the ancestry that it is expected to inherit. And so this light gray is Avon Park ancestry, so ancestry from original birds at Avon Park. We could have a situation like this where a bird has some of its ancestry from Avon Park, but maybe one of these other translocation donor populations. This is the ANF Apalachicola population. And then we could have a situation where we have a mixture of even more ancestries. And so what we're looking at here is all of these little slices of individuals with their ancestries stacked up on top of each other. This top individual here you can see is fully salmon, and that represents one of these translocated individuals that has all of its ancestry from this Apalachicola population. And so we can look at that through time because we know how individuals are related to each other and who's around each year. And so what we can see is that both the ancestry from these donor populations are increasing in the population, and these ancestries are increasingly becoming mixed within individuals. If you look horizontally, there's a mixture of different colors within each individual. And so this is pretty clear evidence that the translocations are diversifying the genetic composition of the population, which is really exciting to see. And so, this is clearly, at least in my mind, a pretty successful example of a pretty successful translocation intervention. So the takeaways that I want you, to have from this presentation is first that, just to make you more aware of this conservation practice, translocations are, a pretty regularly used conservation approach. for birds and also other groups, and this has benefited species in Minnesota. Second, carefully implemented translocations can be a really important and effective, element of the avian conservation toolkit. I've showed you one clear example of that today. And then kind of a broader takeaway is that, this population and the translocations and all the monitoring represents this sustained and pretty, integrative effort between several different groups, including this Archibald Biological Station, as well as government agencies like the U.S. Air Force and the U.S. Fish and Wildlife Service. And so the only reason that we have any of this information, and really the only reason that this population still exists, is because of all the efforts of these different groups. And so I think that this represents a really clear example of the importance of sustained investment in conservation in our public lands, and more generally in our country's, natural resource management agencies, because that's the only reason that some of these endangered species are still around. And so with that, I just want to, thank you all for listening, acknowledge all of my, collaborators on this and everyone that has supported, monitoring this population over time. And with that, if there's time, I'll take any questions if anyone has any.
Thanks, Alex. That was really great. So first, we just have in the comments a story from Larry about having seeing red cockatids at Fort Bragg, North Carolina, when he was stationed there early 90s, and having banded trees marking their nesting areas. And then there is a question from Kevin. Do you see any possible translocations of value or that are possible in Minnesota, such as below links to restore prairies that currently do not have them?
Yeah, I think there are certainly species that could benefit from this in Minnesota. One to mind are prairie chickens. There has been some, I think, efforts to do some translocations with prairie chickens in Minnesota with, I think, varying levels of success, but they've been used pretty effectively in other parts of their range, and they certainly kind of fit this same mold of this woodpecker species where they are kind of, stuck in these little isolated prairie patches that and they can't probably disperse that easily across them. So that's one example of a species that could, I think, benefit. And there's probably, certainly other prairie species, for example, that could benefit from this in the state.
Great. I don't see any additional questions, so I think thank you again, Alex, and I'll pass things to Jen again.